Dear students, under the topic canonical forms, here we are going to learn the canonical form for hyperbolic equation. So under that we have a problem which says that classify and reduce the equation to a canonical form and solve it. So now here we have an equation that is given. So let us mark this equation as equation 1. In our previous video, I have explained the steps involved in transforming a given partial differential equation into a canonical form. So now we are going to follow those steps and solve this problem. So let us review what is the first step. The first step is compare the given partial differential equation with the standard PDE. So this is the standard PDE. We have to compare the given partial differential equation with this standard PDE, and we have to obtain the values of A, B, C and so on, and we have to write that. So let us do that now. So I have taken that and I have written here. So step 1 is comparing the given partial differential equation, that is this equation 1, with the standard PDE. So this is the standard PDE. Now when we compare these two, we observe that here we have uxx and here the coefficient of uxx is a. So the value of a will be equal to 3. So first we have to write that. So a is equal to 3. In a similar manner, if you see, here we have 10uxy and here we have buxy. And so the value of b is equals 10. So that we have to write. And then we have cuyy and here we have 3uyy. And so the value of c will be equal to 3. So that I have written here. And if you observe, the remaining terms are not there in equation 1, which means the value of d, e, f and g are all equals 0. So d, e, f and g. So all these values are equal to 0. So this is the first step. The second step is step 2, that is find the discriminant value b squared minus 4ac. And after finding this, as per the value that we obtain, we have to classify the given PDE as follows. So if the value of b squared minus 4ac is greater than 0, the given PDE will be of hyperbolic type. If it is equal to 0, it will be of parabolic type, and if it is lesser than 0, it will be of elliptic type. So let us evaluate the value of b squared minus 4ac now. So from the obtained values, we are going to find b squared minus 4ac. So that is equal to, the value of b is 10. So 10 square minus 4 multiplied with 3 multiplied with c, which is equal to 100 minus, c is 3. So 3. And then that is equal to 4 multiplied with 3 and again multiplied with 3. So 4 3 times is 12. 12 multiplied with 3 is 36. So 100 minus 36, and we obtain the value of b squared minus 4ac as 64, which is greater than 0. So therefore the value of b squared minus 4ac is greater than 0, which implies that the given PDE, so the given partial differential equation, that is equation 1, is of what type? Is hyperbolic. So is hyperbolic. Because here we saw, if b squared minus 4ac is greater than 0, then it will be of hyperbolic type. So that we have classified the given equation and we have found that the given equation 1 is of hyperbolic type. So this is step 2. Next we have to move on to step 3. So what does step 3 say? We have to find the characteristic equations. Now we have classified the given PDE as hyperbolic. So if it is hyperbolic, then the characteristic equations are given by these two. So let us take this and write now. But here for hyperbolic we have dy by dx to be this, and here we should have a negative sign. So kindly make that change. So negative of this value. So kindly make this change while writing the formula. It should be negative of this value. So these two are the characteristic equations. So let us find them now. So I have taken that and I have written here. To find, third step is to find the characteristic equations, and because we have classified this as hyperbolic, so the characteristic equations are these two. So let us let us find these two now. So now from this dy by dx will be equal to, already we have taken and written the value of b. The value of b is 10. So it will be minus of minus 10 minus square root of, we have already evaluated the value of b squared minus 4ac to be 64. So let us substitute that. So 64 divided by 2 multiplied with the value of a we have got to be 3. So we have to substitute all the values. So therefore dy by dx will be equal to minus of, so minus 10 minus the square root of 64 is 8. So 8 divided by 3 2 times is 6. And so that will be equal to minus of, so minus 18 divided by 6. So that's equal to, minus into minus will become plus, and then 18 when we cancel out it becomes 3, and so here we will have 3. So therefore dy by dx, the first characteristic equation we have obtained to be equal to 3. So let us mark this as equation 2, and then we have to solve this. So the second characteristic equation is dy by dx is equal to minus of, so the value of b is 10, so minus b plus square root of b squared minus 4ac is 64 divided by 2 multiplied with 3. And so on simplification we get this to be equal to minus 10 plus 8 divided by 6, and that is equal to minus of this is 2 divided by 6, and so when we cancel out here we get 3, and so dy by dx is equals, so again we have a negative sign here because we have minus 10 plus 8, and so minus into minus will become plus, and so we will be having 1 by 3, and let us mark this as equation 3. And so we have obtained the two characteristic equations, that is equation 2 and equation 3. So the next step is step 4, that is we have to integrate the characteristic equations to obtain xi and eta. So let us do that. So first we will integrate equation 2. So now dy by dx is 3. So we can rewrite this as dy is equals 3 dx. Now integrating on both the sides, from this what do we obtain? So we obtain to be, I will write here. So integrating dy we get y equals, integrating this, there is 3 is a constant, integral dx is x plus a constant will be added, and because we are having 2 we can write this as c1. And now this is after integrating equation 2. In a similar way we can integrate equation 3. So first we will rewrite this equation 3. So equation 3 becomes, so it will become 3 dy is equal to dx. So now integrating on both the sides we get this as 3y, okay, equals integral of dx is x plus a constant c2. And now from this we obtain the value of c1 to be equal to y minus 3x. So y minus 3x. And so we will be taking this c1 as xi. And so xi will be equal to y minus 3x. In a similar way, so from this c2 will be equal to 3y minus x. And so the value of eta will be equal to 3y minus x. And so we have obtained the value of xi and the value of eta as well. The next step is to find the transformed canonical equation, that is this. The transformed canonical equation is given by this equation. So in this we have to find the values of a bar, b bar, c bar, d bar, e bar, f bar and g bar, and we have to substitute. So how do we find those values? Here we have the values, that is a bar is equals this. So let us find this. So in order to find all this, we need xi x square, xi x, xi y square, and then here xi x, eta x. So all these values we have to first find separately by using xi and eta, and then we have to substitute here. So let us first find them separately. So I have taken and written the values here. First we will find xi x. So that is equal to the partial differentiation of this with respect to x. So y will be treated as constant, and so the differentiation of this will become 0. And here we have minus 3x, and so this will be equal to minus 3. And then we have to find xi xx. That is, we have to differentiate this with respect to x, and because this is a constant, we will get that to be 0. In a similar way, we have to find xi y. That is, differentiate this partially with respect to y. So x will be treated as constant, and so this term will get vanished after differentiation. So the differentiation for y is 1. And then xi y. So we have to differentiate xi y for that. And this is a constant, and so we obtain this value to be 0. And then in the formula we also have xi xy. That is, we have to differentiate xi x with respect to y. So this one, when we differentiate with respect to y, again this will also be 0, because anyway this is a constant. So when we differentiate a constant, it's going to become 0 only. In a similar way, let us do the same for eta. So for eta, we have to first find eta x, which is equal to partial differentiation of this with respect to x. So this term will become 0, and the differentiation of negative x is negative 1. And then we have to find eta xx. So the differentiation of negative 1 is 0. And then we have to find eta y. The differentiation of this with respect to y will give us the value 3. And this will become 0. And after that, eta yy. The differentiation of this is 0. And eta xy we have to find, which will be equal to the differentiation of this with respect to y, and that will be equal to 0. Also in the formula, we have xi x square, which is equal to square of xi x, which is negative 3 square, which is 9. And also we have xi y square, which is equal to the square of this. So square of 1 is 1. So these two also we have obtained. In a similar way, we also have eta x square, which is equal to the square of this, so which is 1, and eta y square, which is equal to the square of this, which is 9. And so we have obtained this now. Now we shall take and substitute all these values here. So first we shall obtain a bar. So what is a bar? Capital A multiplied by xi x square. So what is capital A? Previously we have evaluated, and we obtained capital A to be equal to 3. So that we have to substitute. So a bar will be equals, capital A is 3, multiplied with, what do we have here? Xi x square. So what is xi x square? Here we have found it is 9. So this multiplied with 9. And then plus we have capital B. So we have already evaluated capital B as 10 from the given PDE. Okay. So plus 10 multiplied with, we have xi x here, and multiplied with xi y. What is xi x? We have found it to be negative 3, and xi y is 1. And then plus the next term is C xi y square. So what is C? Already we have evaluated C to be 3. Multiplied with, what is xi y? Xi y is equals 1. So 1 square. Xi y is 1. Here we have xi y square, which is 1. Because, yeah, so this is 1. And so that is equals, so 3 9 times is 27. And when we multiply all this, we get negative 30. And then plus 3 into 1 is 3. So which is 30, because 27 plus 3 is 30. 30 minus 30 becomes 0. So the value of A bar is equal to 0. And then now next we have the formula for B bar. So using this formula, we have to find the value of B bar. So now we shall substitute in this formula. So that will be equal to 2 multiplied with, already we know A is what? 3. Okay, so we shall substitute that 3. What is xi x? Xi x is negative 3 multiplied with eta x. So eta x is negative 1. So negative 1. And then plus, what is b? B is 10. So 10 multiplied with xi x. So xi x is negative 3. Eta y. So what is eta y? It is 3. So eta y is 3. And here we have a bracket like this because b is common to these two terms. So plus xi y. What is xi y? It is equals 1. So 1 multiplied with eta x. Eta x is negative 1. So negative 1 plus 2 multiplied with c. What is c? The value of c is 3. So 3. And then xi y. The value of xi y is 1. So 1 multiplied with eta y. Eta y is 3. So now we shall simplify this. So now because we have negative and negative, it gets multiplied and it becomes positive. And 3 times is 9. 9 2 times is 18. Okay. And then now here plus 10 multiplied with, now here we have minus 3 multiplied with 3, which becomes minus 9. And then minus 1. And then 2 multiplied with, 6. 3 6 times is 18. So this is 18. So further we simplify this and we get it to be, so this 18 plus 18 will give us 36. And this is minus 10 multiplied with 10 will give us minus 100. So this is equal to minus 64. So the value of B bar is equal to minus 64. So we have evaluated the value of B bar. Next we have to evaluate the value of C bar, D bar, E bar and F bar in a similar way. But if we see here we have eta x square. And here also we have, and here we have eta y square. And what if we see here, so eta x square, if we see here, it is equals to 1. So let us substitute all these values. So C bar I have taken and evaluated. So this is C bar. So when I substitute each of the values, we obtain it to be 0. So the value of C bar is equal to 0. In a similar way, we have to find other values by using this formula. And when we do so, we observe that the value of D bar, E bar, F bar, G bar also turns out to be 0 only. So we will write that. Maybe you can evaluate and check it out, but it turns out to be 0 for this problem. So now we have to take and substitute each of these values that we have evaluated, that is A bar, B bar, C bar, D bar, E bar, F bar and G bar in this transformed equation, that is this equation. So when we substitute A bar, C bar, B bar, C bar, D bar, E bar, F bar and G bar in this equation, we get the transformed equation. So let us do that and see what we are getting. Now because the values of A bar is 0, C bar, D bar, E bar, F bar and G bar all are 0 except the value of B bar, which is 64. We obtain 64 u xi eta is equal 0. So this is the resulting transformed equation. Now if we solve this equation, we will get the solution of the given PDE. So now from this, obviously because right hand side is 0, this constant also vanishes when we take it to the right. And so we get u xi eta to be equal to 0. Now actually, what does this mean? The function u, when differentiated first with respect to xi and then with respect to eta, is equal to 0, which means the function u will be, that is u of xi comma eta will be functions of xi plus functions of eta. So on partial differentiations of these two functions, first with respect to xi and after that with respect to eta, is turning out to be 0. So on integrating this with respect to eta and xi, we will be obtaining this. So generally what is xi? Already we have found xi and eta. We can take and substitute them here. So xi here we have obtained, which is y minus 3x, and eta is 3y minus x. So let us substitute that. So therefore u of xi comma eta will be equal to f of y minus 3x plus f of 3y minus x. So this is the required solution of the given partial differential equation. So therefore first we classified this as a hyperbolic equation, and then we transformed it into a canonical form, and then we solved it and we have obtained the solution to be this. This is how we have to solve the hyperbolic partial differential equation by using the concept of canonical form. Hope you have understood this concept. In our next video, we will be learning parabolic type and the elliptic type. Thank you.